Welcome all. In last video, we discussed about public key cryptography. In this video, we are going to discuss about RSA algorithm, which is the most widely used and prominent public key cryptography algorithm. In this video, we'll see about the history of RSA algorithm and what are the features of RSA algorithm and how the algorithm works. Just we will recall that we already discussed in the previous video about public key encryption that we are having a sender and receiver, and the sender know the public key of all other users, but it know the private key of sender is only confidential to that user. Similarly, for the receiver is aware of public key of all other user, it has its own private key. And we know that we may encrypt using one key. For example, here I have users private key of A user to encrypt. Then I will use the public key of the A to decrypt. So I should use encryption with one key, either private or public key, and decryption with other key. It's a pair of public and private key. Now, let us start with RSA algorithm. It was developed by Ron Rivest, Addis Shamir, and Len Adleman in 1977 at MIT, Massachusetts Institute of Technology. In short, we call it as RSA. It refers to the three developers. So actually, these two are scientists, computer scientists, River and Shamir, along with a mathematician called Adleman. And it is the first practical public key crypto system. Even though earlier a lot of systems have been theoretically proposed, this is the first public key cryptographic algorithm which come into existence practically. So the main features are both public key and private key are interchangeable. This is the most valuable feature here. I can make the shift between the public key and private key. There's no difference here. I can interchange the role of public key and private key. There is a meaning. Next one is the variable key size. It can work for 512 key size or 1024 or 2048 bits. And it is best known for and widely used public key scheme. And the mathematical foundation is it is based on exponentiation. Exponentiation of integers over finite field or Galileo's field over modulation. So using the modulo prime number it is the fundamental of RSA algorithm. Now, these are the steps for the RSA algorithm. First step, each user should generate a public or private key pair by selecting two large prime numbers at random. So the first step, selection of two large prime numbers that is called as P and Q. And from that, we are going to compute their model. That is n equal to P into Q, product of two prime numbers. Next, I am going to calculate the pi of n. We already know the previous videos, we watched that pi of n is Euler's torsion function, which is given by multiplication of p minus 1 and q minus 1 because p and q are prime numbers. Second step, we have to select an encryption key called E. I'm going to select the encryption key at random. I can choose any number with only one condition that that number should be in the range of 1 to pi of n. So the range of 1 to pi of n. And that number should have GCD of 1 when it is have with pi of n. That means E and the selected number E and pi of n should be co-prime to each other with the meaning. And then we have to solve the following equation to compute and find the decryption key called D. The equation is E into D equals 1 mod pi of n. The meaning is encryption key and decryption key are inverse to each other. They are modulo inverse in arithmetic modulation. And then we are going to publicize the encryption key. Encryption key is a pair of E comma N. Similarly, the private key, the decryption key is D comma N. So this is the RSA algorithm. How we are going to use this public key and private key? Let us see the usage. To encrypt the message M, what will the sender do? The sender will obtain the public key of the recipient, that is E comma N. So he compute the ciphertext called code word C equals M power E mod N. And then we will decrypt the ciphertext in the decryption side such that it uses the private key. It's a pair of D comma N. So it computes message M equal to C power D mod N. So this is how we are going to use the RSA algorithm for encryption and decryption. Let us just recall what we need to do. First thing is selection of large prime numbers P comma Q and N equal to P into Q, and we are going to compute pi of N equal to P minus 1 into Q minus 1, and we are going to select one private key called E such that E should be in the range of 1 to pi of N, and GCD of E comma pi of N should be 1. That is, the selected number E and pi of N should be coprimes. And we have to find the decryption key D such that D is the modulo inverse, multiplicative inverse of E, encryption key in mod pi of N. And by the public key is KU, it's a pair of E comma N, and private key is D comma N. Then for encryption, I'm going to use the messages M. For example, the message is I'm going to give a word like hi. Then I need to convert this into corresponding numbers. So when you represent A to Z in 1 to 26, H will be 8, 8 will be 1, I will be 9. Am I right? Then I have to apply 8, 1, 9. Separately, I have to apply RSA algorithm. Here first M is 8, then M is 1, M is 9. Like that, I'll get the message. Then I'm going to take M power E mod N and M equal to C power D mod N. Use your RSA algorithm. Thank you.